All right, guys, welcome back today. I think we're going to take a step back just to make sure that we are good with factoring. And I think before we do that, to recognize some patterns, we're going to have to multiply binomials first. So we're kind of reversing a little bit, and then we're going to keep going on with the review, and then eventually we will get on with new material. So for a thing slash warm up, I have how do you multiply 2x times 3x minus 1? And the answer to that would be you would just multiply 2x by 3x and then 2x by minus 1. And can you use that knowledge to learn how to multiply 2x plus 3 in parentheses times 3x minus 1 in parentheses? My hint here is to think of 2x plus 3 as a single number, which, if you think about it, 2x plus 3 kind of is a single number, right? If x was 1, then 2 times x would just be 2 times 1, which is 2, plus 3, 5, and 5 would be a single number. And if it was a single number, we would be able to distribute it just in like that. And that's what we can do, right? So if we distribute that 2x plus 3, 2x plus 3 times 3x, well, can't we just rewrite that as this? And then similarly, 2x plus 3 times minus 1, wouldn't that be the same as minus 1 times the entirety of 2x plus 3? Well, now we can just distribute how we like to distribute. And that's exactly what we're going to do. It's still the distributive property. It's just little extra steps. And another way to think about it is that this means that this number has to get multiplied by everything else in that other binomial. So 2x has to get multiplied by 3x and by negative 1. And then once you're done with that, that 3 has to be multiplied by 3x and by negative 1. That's how I like to think about it. So to just get ready first, let's get a little used to what multiplying things are, especially once we get to multiplying variables together, what that equals. 4 times 6, we know what 4 times 6 is. That's 24. Now 4 times 6x, that's just, we can multiply in any order, right? So if we multiply in any order, that's 4 times 6 times x, right? 4 times 6 is 24, and then we just leave that x out front. And then here, same thing, 6 times 4x. Well, that's the same thing as 4 times 6x. We can just do the numbers first and leave that x out front. And now down here, same thing, right? We have 4, this is 4 times x times 6 times x when we write it out like that. But we can multiply in any order we want, so why don't we do 4 times 6 and then put the x's together? And so the real trick is when you see something like this, do the numbers first, right? 4 times 6 is 24. And then do the variables. We have an x here and we have an x here. X times x is x squared, right? We end up having 2 of those x's multiplied together. And then finally putting that all together. Remember, we can do the numbers first. So let's just do 3 times 7 first, which is 21. And then how many x's do we have? We have 3 x's here, and then we're going to multiply by 2 more x's. That would give us x to the 5th. And then we have a single x here and 2 more, or y, sorry, we have a single y here and 2 more y's there. That'll give us 3 y's, right? Because if we were to write out how many x's there were, it would be x times x times x, that x cubed. And then that 7x squared has x squared, which is x times x. And then there's 5 of them, right? So it's a good note that we're adding these exponents. We're not multiplying them. We're multiplying the bases, but we're adding those exponents. And that would be our final answer for that. So again, I just do numbers first and then the variables after. So example 1, multiply the 2 binomials. And again, I'm going to do my trick above where I'm going to say I'm going to take this first one and I have to multiply it by everything. So x times x is going to give me x squared. X times positive 6 is going to give me 6x. Now I've done everything there. Now I have to do this negative 7. Now negative 7 times x is negative 7x. Negative 7 times positive 6 is going to be negative 42, right? And now we have some like terms, right? we have plus 6x minus 7x. If we have positive 6 of something and we take away 7 of that something, we should have minus 1 of that something left. So plus 6x minus 7x is going to be negative 1x, which is the same thing as just negative x. And then that minus 42 is still out front. And when we are multiplying these things, let's just take note of a couple things, right? We have a negative invisible 1 in the middle here. Notice how negative 7 plus 6 adds to that negative 1. And then notice how negative 42 is multiplied by negative 7 plus 6. Keep that in mind moving forward. Now this one, same thing. I'm going to do 3x times 2x. Do the numbers first. 3 times 2 is 6. And then x times x is x squared. 3x times minus 3 is going to be minus 9x. Now we move on. Negative 5 times 2 is going to be negative 10x, negative 2x, sorry. Then negative 5 times negative 3, the negative times the negative is a positive, and then 5 times 3 is 15. And then again, we have some like terms that we can combine together. Minus 9 of something minus another 10 of something is going to be minus 19 of that something, which is x, and then plus 15. And now for this one, this is an important one. 2x plus 1, the entire quantity squared. Everyone wants to just kind of put that 2 in there, but that's a no-no. That's not what we're supposed to do. Because think of what squared means. When you square something, that means you take something and you multiply it by itself. So what this really is 2x plus 1 multiplied by itself. And now we can multiply it just like any other thing. We're going to do 2x times 2x, which is going to be 4x squared, 2x times 1, which is positive 2x, 1 times 2x, which is another positive 2x, and then 1 times 1 is plus 1. We have 2 like terms in the middle. This will turn into 4x squared. 2x plus 2x is 4x, and then we're adding 1. All right, so now we're going to multiply these binomials together, and we're going to look for some patterns. So first we're going to get x times x, which is x squared. And then we're going to get x times 4, which is 4x. And 8 times x, which is 8x. And then 8 times 4, which is 32. And now we have like terms we can combine in the middle. So that's going to give us x squared plus 4 plus 8 is 12x plus 32. And here's where I want us to look for some patterns. Let's erase this and just look at this for a second. Well, I'm sure you've been noticing every time we do the x times x, we're just getting a single x squared. Now, what does this plus 12 have to do with anything up here? I would take notice that 12 is 8 and 4 added together. And then this 32 is 8 and 4 multiplied together. I wonder if that pattern continues. Let's find out. So z times z is going to be z squared. Z times plus 3 is plus 3z. Minus 6 times z is minus 6z. And then minus 6 times plus 3 is going to be negative 18. And again, we have like terms in the middle. So we have z squared. 3z minus 6z is going to be minus 3z. And then minus 18 is up front. And again, let's look for some patterns. So let's get rid of this and let's look for some patterns. Again, z squared just comes from z times z. Now this negative 3, I should put this in for my z's so that you know they're z's. This negative 3z, isn't that negative 6 plus 3? There's that connection again. And then here's this negative 18, and that's from the negative 6 times the positive 3. I think we might be starting to see a pattern emerging. And now my advice would be to kind of use this pattern emerging so that maybe we can jump forward a little. So if we did this, that would be p squared. And then I know I'm going to get a minus 10p and a minus 3p, which together, these two numbers added together is negative 13p. And then we can do negative 10 times negative 3, which is positive 30. And that's our answer there. So that's just an example of maybe being able to think ahead and use those patterns to your advantage. If that's too fast for you or confusing, don't be afraid to just multiply everything out like we did up here, right? One by one. Don't be afraid to do that and then combine the middle terms. But if you can, I would encourage thinking like that if you can see that pattern easily. So now we're going to do it here, x times x. And it looks, I'm already looking at this and I'm like, oh, we kind of have a weird relationship. We have x and 7 and x and 7 again, but the signs are different. So let's see what happens then. So the x times x, because that's x squared. X times minus 7 is going to be minus 7x. 7 times x is going to be plus 7x. And then 7 times negative 7 is going to be minus 49. Oh, look at that, minus 7x plus 7x. Those will cancel each other out. We're just going to be left with x squared minus 49. Now notice 49 is a perfect square because we got it from 7 times 7, and we don't have a middle term. That'll come up later again with our difference of squares. And one last time, we have another squared. So, but I kind of want us to see the pattern of what happens when we are squaring something. Remember, we can't just put that squared in because this means y plus 4 times y plus 4. And if we go out with that, y times y is going to be y squared. And then we're going to get 4 times y, which is 4y. And then we're going to get another 4 times y, which is 4y. And then 4 times 4, which is 16. And so the pattern here, once we combine like terms in the middle, 4y plus 4y is 8y. If you can kind of see it, when we squared something up here, if you can visualize in your head that you're going to get another y plus 4, then you can see that you're going to get 4y and another 4y, which doubles it. So, right, so this is actually going to get doubled for the middle term, and then 4 times 4 is going to get, so essentially, and then 4 squared is going to end up at the end. But again, if you can't see that pattern and you don't want to jump, just multiply it out like that every time and then combine like terms. And so now we're going to kind of use that to factor. So we need numbers, and the pattern was we had, so for factoring, we want it to look like these two binomials, right? And our patterns, we recognize that, we could put x and x there, and that would give us a 1x squared. And now we need numbers that multiply to our last number, which is 32, and add to negative 12. And you guys, I think, used to do this by looking at a box, right? So we need to multiply to 32. I'll put an m there for multiply. And we need to add to negative 12. And you need to find two numbers that do that. And the two numbers that I can think of are negative 4 and negative 8. Because negative 4 times negative 8 is a positive 32, and added together they get negative 12. And then you can just put them right in there. And hopefully seeing those patterns for multiplying polynomials earlier is kind of helping you, right? Because we would get our x squared minus 4x minus 8x, which is that minus 12x, and then negative 4 times negative 8 is plus 32. So now it's about using those patterns that we've noticed backwards. So now looking at this one, we need numbers that multiply to 25 and add to negative 10. And what two numbers do that? Ooh, this one might be a little weird, but I see it. I think that's going to be minus 5 and minus 5. So we have two of the same numbers. What do we do with that? Well, we could still just put that in like that. But there's a nicer way to write this, isn't there? Isn't z minus 5 times itself the same thing as z minus 5 squared? Boom, are we kind of seeing that pattern now? Where that z minus 5 squared, we have double that number, and then we've multiplied it by itself, so that's that number squared, negative 5 squared. And then for our last one here, again, t squared, we could probably just start writing our fractions like that. And now we need two numbers that multiply to 16 and add to 17. Oh, just 1 and 16 can do that, right? 1 times 16 is 16, and 1 plus 16 is 17. So that's just t plus 1 plus 16. And again, you could check any of these answers by multiplying these back out, right? We would get t squared plus t plus 16t plus 16. And then combining like terms, we would get t squared plus 1t plus 16t is 17t plus 16. And that's what we started with. So we know that this is the right answer.